Today we are graphing more rational functions. It is November 11th. I mean, November 1st, that was 11/1, rather. Which makes me happy that it's November, because then it's like Veterans Day, and then it's Thanksgiving, and then it's whatever. All right. I'm gonna go pretty quickly through these. I have 4. I'm only gonna do 2 problems with you. So we know a bunch of things. We are gonna be again talking about domain and vertical asymptotes. We're also gonna be talking about holes or discontinuities in the function, which we have to be careful of, and we want to find those first. So here is some general information that's very, very useful. So for any rational function, this is my notation. A rational function is formed by a polynomial in the numerator and a polynomial in the denominator. So n of x just represents the numerator polynomial, and then d of x just represents some denominator polynomial, all right? Now, I have some more notation here. Ax to the n, little n. So maybe your numerator polynomial is like 3x squared plus 2x plus 1, or something like that. So it's a polynomial in the numerator, and this power of n represents the highest power in the numerator, essentially the degree of the numerator. And maybe our denominator polynomial is like 3x squared minus 1, or something like that. I don't know. But again, this little d just represents the degree of the denominator polynomial. And for whatever we do, the first thing that we want to do is factor, if we can. We're going to learn a ton of information just by factoring. And when we factor, we'll get a whole when there's a common factor on top and bottom. Because what happens is, if there's that common factor on top and bottom, like an x plus 3 on top and an x plus 3 in the denominator, then we could simplify that function and make it smaller, which is nice. I don't want to do that. But what it does is, when you have that common factors, it's going to create a hole in the graph. Kind of different than a vertical asymptote. So we want to pay attention to that. Domain. Where does domain come from? Always, always. Denominator domain. Very good. D-E-N-O-M-I-N-A-T-O-R. Denominator domain. Denominator domain. Whatever the denominator is, we get our domain from there. Always, always. Now, once you know the denominator, the domain, we can also, it helps us get the vertical asymptotes, but you need to be careful. We don't want to include any holes. You can't, if it's a hole, it can't also be a vertical asymptote. All right, so be a little bit careful. Don't include any holes in those vertical asymptotes. So we'll go through one of them and you'll see that. Now, the horizontal asymptote, there are 3 different cases here. This is a little n. This is referring to the degree of the numerator. The degree of the numerator. And this is little d, and it refers to the degree of the denominator. And so to figure out what the horizontal asymptote is, we just need to look at the powers, the highest powers for the numerator and denominator. If the degree of the numerator is smaller than the degree of the denominator, so if it's like x to the first over x squared, then our horizontal asymptote is always y equals 0. Okay. If the degrees are equal, so let's say we had some function that was like 2x squared over 4x squared. Here, our powers are equal. And since the powers are equal, all we have to do is sort of reduce those leading terms, and we get 2 over 4, which reduces to 1/2. So our horizontal asymptote is just that reducing the fraction, just about. Tomorrow, or Monday rather, we're going to be looking at what happens when our degree of the numerator is higher than the degree of the denominator. I like to call those top heavy. And H-E-A-V-Y, not E, heavy. Top heavy, meaning we have to divide, okay? We can reduce that by long division and write it in basically the form we had yesterday, okay? So long division helps us simplify our functions. How do you find x-intercepts? Also known as zeros. Yeah, plug in 0 for x or?
0 for y.
There you go. Set y equal to 0 and solve for x. And then how do you find a y-intercept? There should only be one, not more than one. How do you find a y-intercept? Yeah, we're going to set x equal to 0 and solve for y. Rather just simplify, but okay. It does say top heavy. All right. So we're going to try some. I want you to write down the directions, but I don't want to do the letter A, so we're not going to do letter A. So write down the directions, and then I'll go to letter B. So example 1, identify the domain, holes, vertical asymptote, and horizontal asymptote, zeros, and graph. Again, you have a graphing calculator. You're going to use your graphing calculator to help you graph. All of these other things, though, which you can check using your calculator, you have to know how to find all the stuff, all the important characteristics. Those are the things I'm going to test you on a multiple choice test. I'm not going to ask you to graph, okay? But I'll ask you, where is the hole of the function? There is a hole. Where does it occur? All right. So those are all the things you want to pay close attention to. All right. I don't see anybody. So there we go. All right. So letter B. F of x equals 3x plus 5 over 3 minus 4x. So I guess you could call this letter A, but whatever you want to do, I don't know. What do you think of the order in the denominator? Is that okay for you? Or do you want to rearrange it? It doesn't matter, but I am going to rearrange it just because I like to draw circles. So I'm going to rewrite it as negative 4x plus 3. This way I can more clearly see my leading terms, and that's really, really important. So the first thing we want to do is we're going to ask ourselves, can we factor at all? Factor first. These are x to the first power, so we cannot do any double bubbling or GCF, anything like that. So we cannot factor. So I'm going to go to domain. We want to find the domain. Where does domain come from? Denominator, denominator. So when we're finding domain, the way that we get that is we say this denominator, negative 4x plus 3, cannot equal 0. And we're actually solving the equation for x. So if I subtract 3 and divide by negative 4, that's where we get the x cannot equal 3/4. So we're actually solving that equation. Once we know that, then I also know the vertical asymptote. What's the vertical asymptote? X equals 3/4. Very good, just like yesterday. Very good. Now we want the horizontal asymptote. The horizontal asymptote, I need to know which case is this. Equal to each other, where the numerator degree is equal to the denominator degree. And when that happens, yeah, all I have to do is sort of reduce those leading terms. And what do you get? Negative 3/4. Very good. So I'm going to make lots of circles like this every time. And notice my color coding too. For this particular one, we can say the range. What's the range? Yeah, y cannot equal 3/4. That's not always true, but for these rather simple ones, it is. Let's see. And then next is zeros. So the zeros or x-intercepts, how do you find the zeros? Set the equation equal to 0. Set y equal to 0. So I'm going to go right here. And when I do that, I get 0 equals 3x plus 5 over 3 minus 4x. How do you solve for the x's? Multiply. Yeah, so one thing you could do is put it over 1, and maybe you would say cross multiply. Multiply by the denominator, if you will. What happens when I do 0 times the denominator? It's 0. Yeah, so it turns out finding zeros happens to actually be pretty easy. What happens to the denominator? It goes away. So we're left with just the numerator. So it turns out that the numerator gives us the zeros. Always. Okay? Just kind of in this form. Let me be specific, in this form. Yesterday's form, that doesn't work the same. But if you just have a single fraction numerator denominator, the zeros come from the numerator, which means that x equals negative 5 over 3. That would be the ordered pair, negative 5 over 3 with a 0 for y. That's a nice point that I can graph. So kind of nice. I don't have to really do an XY chart necessarily. I also want to find the y-intercept also, since it's a good thing to know how to do. How do you find a y-intercept? Set x equal to 0. So we have y equals 3 times 0 plus 5 over 3 minus 4 times 0. Again, an easy thing to do when you're plugging in zeros, we're going to be left with 5 over 3. So my y-intercept turns out to be 0 for x and 5/3 for y. So that's another ordered pair that we could graph. Okay. So I'm going to go ahead and make a sketch of all this information. Let's see. We've got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Pretty fast sketch. My vertical asymptote is at x equals 3/4. That's about right here. Not quite 1. So x equals 3/4. My horizontal asymptote is at y equals negative 3/4. That's about right here. Just below the axis a little bit. So y equals negative 3/4. Andy, I can totally hear your music.
Sorry.
It's really irritating. Negative 5/3, 0. That's like negative 1 2/3. That's about right here. I'm going to label that point. Negative 5/3, 0. And then I also have the point 0 5/3. So 0 5/3 is not quite 2. So that point is 0 and 5/3. And again, we're going to get those L-shaped graphs. So I have 2 points here that my graph is going through. So I only have points to the left of my asymptote. So what do I need to do? I need to use my calculator and find some more points. So use your calculator, plug in your function. Make sure you put parentheses around the top and the bottom, the numerator. So 3x plus 5 divided by 3 minus 4x. I'm always, always, always going to plug in the original function. Don't plug in any function that you changed because you might have made a mistake. Okay, so always plug in the original. So I have that plugged in. I'm going to graph it, and I can see that it looks pretty close to my graph here. What I'd like is another point on the right side. So what's an x value I could find? 1. I could do 1. I could also do 2. I've got a calculator. I'm going to trace and do 2, and I see that it's 2, negative 2.2 on my calculator. I just need 1 point, and that's just fine. So use your calculator to help you graph. I can check everything, though, since I have it here. What's going to happen when I plug in 3/4? Yeah, nothing. It's not defined. So there is no answer there. And that's where we get that vertical line. I can check these points as well. If I plug in a 0, I get 1.66666. That's 1 2/3. So that's that point there. And negative 5/3. I don't know what is going on behind me, but again, negative 1 2/3. All right. Questions for me? That's good, right? Look at all the circles. The denominator domain, the vertical circle here is the horizontal asymptote, and the numerator gives me the zeros of the function. So lots of circles help out a lot. All right, the second problem I want to do is this one. Oh, see, this is not. All right, we'll do this one. I think we will. Hold on. Okay. We're going to call this letter B. Wait, it's like you can't even tell. And x equals x squared minus 2x over 2x squared plus 3x minus 14. I hope this does what I'm hoping it'll do. I did different problems during first period. Okay. No, they had some too. Yeah. Can we factor? Yes. What can we do in the numerator? Take out an x. Do not forget about the GCF. There's the most forgotten factoring method is the greatest common factor. If I take out an x, what's left behind? X minus 2. Very good. And then my denominator, can I factor that? Yes, let's give it a try. 7 and 2. Okay, so I have 2x times x will give me my 2x squared. And a negative 7 and a positive 2 would give me my negative 14. I'm going to put my positive 7 here and my negative 2 here. How do I know if I did it right? Check the rainbow. The rainbow, I have a negative 4x. 2x times negative 2 is negative 4x. 7 times x is 7x. And when I add those up, I get my middle term. So I did do it right. Now, what do you notice since that happened? We have a common factor. Look at that, another circle to draw. And it's a hole, and you'll notice I'm drawing holes. Okay, so there is a hole at x equals what?
2.
X equals 2. So that's great and all, but it's not super helpful. And I like things to be helpful. So what I actually want to find is the location of the hole. I actually want the ordered pair where the point isn't. Okay? So if I were to take an x value and plug it back in, if I plugged it into one of these bubbles, I would just get 0. Well, that's not helpful at all. Normally, we would simplify, we'd reduce, and we're just left with this. Okay? What I'm going to do is go ahead and plug my 2 in for those x's. So that gives me 2 over 2 times 2 plus 7. And I get 2 over 11. Which means there's a hole at the x value of 2, and 2/11 is the output. So I have the exact location of the hole. I can actually draw a little open circle there, and that's kind of extra information. That's pretty nice. 2 over 11, 2/11. Okay, so domain. Where does the domain come from? Denominator. The whole denominator. The original denominator. We have 2 bubbles, which means there's 2 exclusions. What is x not allowed to be? 2, and x is not allowed to be negative 7 over 2. Very good. So again, subtracting the 7 and dividing by the 2 gives us negative 7/2. Now, What are the vertical asymptotes? X equals negative 7/2. What about the x equals negative 2? Or sorry, x equals 2. It's a whole. Very good. It's a whole. It can't be both. And the whole trumps everything else, okay? So it can't be a whole and a vertical asymptote. All right. Then, that's very good. I can graph that. We want to find the horizontal asymptote. What case is this for the horizontal asymptote? They're equal, where the degrees match. So what is our horizontal asymptote? 1/2, very good. So when the degrees match, it's real easy. We can just reduce those leading terms. The x squared's reduced, and we're left with 1/2. You could talk about range, but I don't really care about the range. What are the zeros? Where do the zeros come from? Oh, the numerator. I already used pink. I can't use pink again. All right, the zeros. All right, where do the zeros come from? The top, the numerator. So right here, my numerator. What are my zeros? 0. Oh, okay, so x equals 0. Can x equal negative 2? No, I can't include that one because it's a whole. It cannot be more than one thing. So it is not a 0. The whole trumps everything. Okay? So we have the ordered pair 0 for x, 0 for y. And then if I want to find my y-intercept, oh, the y-intercept happens to be 0. 0 divided by 14 is 0. It's the order. Okay. It's a double intercept. It's an x and a y-intercept. All right. So making a sketch here. I have a vertical asymptote at negative 7/2. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So negative 7/2 is like here, negative 3.5 for my vertical asymptote. My horizontal asymptote is at y equals 1/2. And I have some points. I pass through the origin at 0, 0. That's a good point. And I have a hole at 2 and 2/11. So that hole right here, 2 and 2/11 is just a little bit above the axis. Right there, I'm actually going to draw a hole. Right there is an open circle at 2 and 2/11. And it's important that you know that it's there. Because when I go to graph this function, will you be able to see the hole? No, you will not. So I'm plugging this into my calculator. You'll notice I only have half of my little L shapes. 2x squared plus 3x minus 14. All right, so I'm plugging that into my calculator. Again, parentheses around the numerator and denominator. And I'm graphing, and you can see that you cannot see the hole because it's one tiny, tiny point out of an infinite number of points. It is infinitely small is what that means. So you'd never know it was there. But if you found it, we could trace. And what are you going to see when I go to trace when x is 2? Is it going to be error? Y, yeah, y is undefined. Yeah. So there's nothing really there. It's excluded from the domain. When I type in negative 7/2, you can see it's also undefined. 0, 0 is the point on the graph. So that one's there. But I need a point on the other side of my function. So what's an x value I could use? Negative 4. Yeah, so I'm going to type in negative 4. Oh, there it is, kind of, sort of. And I get 4. 1, 2, 3, 4. So right about there, label it -4, 4, and then I can finish my L shapes. All right, so really that is an open circle. Got to look out for those common factors. Do you guys have any questions for me? All right, should be able to get this done